This is question number 8 on quiz 6 for chapter 5. Imagine that Homer Simpson actually invested $170,000 6 years ago at a 13% annual interest rate. If he invests an additional $1,500 a year at the beginning of each year for 5 years at the same 13% annual rate, how much money will Homer have 5 years from now? So basically, to better understand the setup, I believe it might help to draw a chart to see what's going on. So this is, suppose this is where we stand, right? So this is negative 13, and this is timeline, just timeline, time flows the right direction. So going to the setup, it says that 13, sorry, it's 13%, it's not 13 years. So it's going back, so you erase that, and this is negative 6. And this interest rate is 13%. So we deposited some money here. How much? Let's going back and check. $170,000. $170,000. 170,000. And then after that, the money will compound to today. And after today, we're gonna do some additional investment. And now it will become an annuity because we're gonna invest $1,500 a year at the beginning of each year for 5 years at the same 13% annual rate. So remember, this is the beginning of the year. So that means first payment actually will start right now, right? So this is where it starts. This is 1,500. So same amount, and this will continue for 5 years. So this is 1, 2, 3, 4, because this is a beginning of the year payment. So the last year is actually 4 years from today, rather than 5 years from today. So that means that's what it means by investing this additional amount every year for 5 years. And it's asking how much money will Homer have 5 years from now. So basically, it's asking this 5 years from now. So this obviously this is future value, right? And this is 5. So it's asking this. And relative to the year 5, we know that this is first, this is annuity, right? But relative to that, this is an annuity due, right? It's an annuity due, AD. So we're going to use the annuity due formula to figure out the future value of this annuity due. And then we will also need to add the future value of this $170,000 lump sum cash. It's 6 years ago relative to the current point, but then another 5 years to go. So 6 plus 5, we're gonna compound this lump sum one-time cash flow $170,000 for 11 years. So then we're gonna add up these two future values, and then that will become our future value. So let me write down what that means. Future value of this $1,500 annuity due, right? So that's the future value 1, and then plus future value 2 of this $170,000 for 11 years. And so the AD is for 5 years, right? So that then once we add up this, and that will arrive at what we need. It's the future value of this total. So now, if we go back to the questions, part A, if Homer invested $170,000 6 years ago at a 13% annual interest rate, what is the future value of this investment 5 years from now? So basically, this is this is what the second, right? This is the second future value we are writing here. So we're going to use the Excel to help us to get the answer. Let me erase that. So that's going to be future value, right? FV, and open that. The interest rate is 13%, 13%. And the NPER, as we said, is 11, right? That's 11 compounding years. And this PMT refers to the annuity payment. It is not annuity, so we should put 0 there. And the present value is $170,000, right? But again, the rule here is that if we just put a positive present value, then we're going to get a negative future value. But if we want to get a positive future value, then we can just add a negative sign in front of this amount. So that will give us the future value for this lump sum cash flow. So just copy that number back. And I need to check the rounding requirement before I do that. And I think it's rounding to the nearest cent. And that's what I did, basically keep 2 decimal places for the dollar. And part B, if Homer invests an additional $1,500 a year at the beginning of each year for 5 years at the same 30% annual rate, what is the future value of this investment 5 years from today? So basically, this is asking for this future value 1, right? 15 years, $1,500 annually due for 5 years. So we can just use, actually, we can use 2 ways to get the same answer. One is to directly work with the future value formula. But now we need to look at these arguments here. The last one is the type. In general, we don't have to touch this argument. But if we want to work with the present value or the future value of annuity due, then we need to change the type. Change it from end of the year convention, which is the default, to the beginning of the year convention. So we're going to show you how to do that later. So the interest rate here is the same, 13%. And NPER, that's the number of annuity payments. So that's 5. And the payment here, again, if we want to work with positive payment, then we're going to get a negative future value. But now we need to, I just put a negative sign in front of the payment. So that will give me a positive future value. The PV refers to the lump sum present value, which is 0 in this case. And then once you get to the type, you can see 0 means end of the period. That's the default. And the 1 means the beginning of the period. That's what we're going to put, because that will give us the annuity due. Right? So we can just put that. And then that's the second way. That's actually in our terminology here. That's the first future value, and then we just need to copy that amount back. And I think I followed this rounding requirement, round to the nearest cent. So as I said, this is just one way to get the future value of annuity due. Another way to get the same amount is still to use the future value formula, but then the only change we're gonna do is to keep the type, which means to keep the default value for type. That means we'll still use this formula, and by keeping the default value, this formula will give us the future value of an ordinary annuity. And once we have the future value of an ordinary annuity, and we know that the relationship between the future value of an annuity due and an ordinary annuity is that we can multiply the future value of an ordinary annuity by 1 plus the interest rate to get the future value of an annuity due. So that's how we can work out the same solution. It's still 5, and it's still negative 1,500 and 0. And actually, after that, we don't have to worry about. the arguments. So multiply by 1 plus interest rate. And you can see that except for the format, so now let me change the format. You can see these two will give us the same answer, just format, and this is 2. And you can see it's the same answer, right? So that also gives us the confidence that this amount should be the correct answer. And see how much money will Homer have 5 years from now. So the rest of the job is simply to sum them up. So that equals the first future value plus the second future value, and then that gives us the total future value. So, and just get rid of the dollar sign and then check my answer. Input is correct.